So, I am honored to present during this Best of ESPID, and before I begin, I would like to thank the Board of ESPID and the Committee for Scientific Affairs and Awards for granting me this fellowship. The fellowship has enabled me to start my own research line and to advance my scientific career. I am currently working as a postdoctoral researcher in Rotterdam and as a clinical fellow in pediatric infectious diseases and immunology in Utrecht in the Netherlands. And during my residency, I was triggered by the detrimental effects of sepsis in newborns. This led to initiation of my own research line called IMPRESS, Immune Mechanisms During Preterm Sepsis. And during this talk, I want to show you my vision of the importance of inflammation during sepsis and also how basic science can improve sepsis-related outcomes. As we all know, sepsis is the body's extreme inflammatory reaction during a bacterial infection. And because I want to improve sepsis-related outcomes, I initially focused on the most vulnerable population, preterm newborns. But already quickly after the start of my project, I realized that also term newborns that are hospitalized, for instance for congenital heart disease, have a high risk to develop sepsis. So currently I am focusing on all newborns that have a high risk to develop sepsis, both preterm and term newborns. As I said, sepsis is characterized by a hyperinflammatory state. So normally during a bacterial infection, the initial phase consists of inflammation with pro-inflammatory cytokines such as TNF and IL-6. In the second phase, resolution takes place with anti-inflammatory cytokines such as IL-10 and IL-1 receptor antagonists. However, during sepsis, that initial phase is exuberant and hyperinflammation exists. High levels of TNF and IL-6 are associated with sepsis, also in newborns. So if we go back to the clinical picture, we know there's a high variation in disease severity between newborns when they get a bacterial infection. And on this slide, the red individuals are newborns with the highest degree of disease severity, sepsis. Those individuals are also the ones with the highest degree of inflammation. So everybody in the room, just imagine that you can identify these hyper-responders already at birth. So could we employ a method before infection to identify newborns that will be hyper-inflammatory during a bacterial infection? This is highly clinically relevant because we can inform doctors who is at risk to develop sepsis. And in addition, if we understand the inflammatory response, we can also think about tailored therapy that focuses on inflammation and not only on the bacteria. So with the fellowship, I was able to establish such a method. And the method consists of two important parts. This is the first part. In week 1 of life, we collect neonatal blood. So not cord blood, but neonatal blood. And we mimic sepsis in our laboratory with in vitro stimulation with either bacteria or TLR ligands. We measure a broad panel of cytokines to get the most complete picture of each individual, the capacity to produce inflammation. The second part, we include newborns that actually get a bacterial infection. And we collect the serum sample during the infection, and we measure the same cytokines as in our in vitro assay. So the most challenging, but also the most rewarding, is of course if you would have the same individual in week 1, you test the inflammation in the lab, and you follow the patient to see whether that can also predict the inflammation when an infection actually occurs. If we go back to the first part, the identification of those hyper-responders at birth before infection occurs. So this is an example, and I have focused on IL-6 and E. coli in the interest of time. And here you can see the in vitro production of IL-6 from healthy newborns after exposure to E. coli. And keep in mind, it's a log scale, so the scale is 10 to 100,000. And initially we thought, well, probably preterm newborns are immature, they have a low IL-6 response. But what you can appreciate from this graph, we have categorized the newborns in preterm below 30 in white, and in gray 30 to 37 weeks of gestational age, and in black are the terms. And what you can appreciate that on average, it is similar between the three groups. So as a preterm, you are capable of producing as much inflammation as a term newborn. The second important message from this graph is that if you pull all these newborns together, you can see a high degree of variation, again in vitro in week 1 before infection occurs. And you can identify low responders and high responders. Of course, IL-6 is not the entire picture. During an infection, a lot of cytokines are produced. And without going into detail, I want to show you this graph, and you see multiple cytokines, pro-inflammatory, but also anti-inflammatory, such as IL-10. And the message from this graph is that if you look at all newborns, there's a high degree of variation for all these cytokines. So to end my presentation, I want to give an example on how you can use this method in a more translational manner. And because we use different bacteria to stimulate the blood, we can also focus on a specific bug. So this is one example from our study, and we focused on Staphylococcus aureus. And we measured the inflammation in vitro in week 1, when the baby was still healthy. And we measured the inflammation in another cohort which had a culture-proven bacteremia with Staphylococcus aureus. The same as for E. coli. In our in vitro assay, again, we see a high variation between individuals. So again, you see the low responders and the high responders with regards to the production of IL-6. In our cohort, you see the same. So in our cohort of aureus bacteremia, you see in the serum a high variation of IL-6. Again, low and high responders. And what you can also appreciate from this graph is that our in vitro method in week 1 and the range of IL-6 is highly comparable with the range of IL-6 that is actually produced in our cohort of infections. So the most exciting part comes when you can follow the same individual from birth to infection. First, I need to say this, because we also have the clinical data. We could confirm that those that had a high level of IL-6 in the serum were the ones with a clinical picture of sepsis. So this is the most exciting part. We followed subject 8. So let me introduce you. Subject 8, week 1, still healthy. We stimulated the blood with aureus, and what you can see compared to all the other newborns, this was a low responder in vitro. Guess what? In our cohort of aureus bacteremia, the same individual, 8 weeks later, so this is 8 weeks after our method in week 1, we also saw that there was a low responder, so low levels of IL-6 in the serum. So these data make me highly motivated to continue my research to identify those hyper-responders at birth. And I'm happy to share with you that with the fellowship I was able to establish such a research line. And the next steps will be to directly compare my method in week 1, follow the same individual, and see whether we can predict the inflammation when an infection actually occurs. In the end, my goal is to think about targeted therapy that targets the immune response and the inflammation of each individual, in addition, of course, to giving the antibiotics. I would like to acknowledge these people from the Sophia Children's Hospital, from the Laboratory of Pediatrics, from the Division of Pediatric Infectious Diseases, and from the Department of Neonatology. Again, a special thanks to the Board of ESPID and the Committee for Scientific Affairs and Awards. And of course, a great shout out also to the parents and the patients that make this work possible. So for me, to take the next step, I am convinced that collaboration is key. So I put my email address here, and if you are as excited as I am, please contact me to set up a collaboration. Thank you.